area equals base times height. E times H. Okay, what's my base total in length? 14. So this whole distance is going to be 14. Now I need my height. No. That's where it changes from geometry to other elementary school. Height, when you go to the doctor, literally talks about how tall you are vertically, correct? Like stand straight, stand up against the wall. Okay. We can't use a slant height to represent our height. So we need to find this height. So how can I find the height of it? Pythagorean theorem. So this is why like geometry is now involved with this, because we are going to do the Pythagorean theorem to find the vertical height of the parallelogram. So if that's my right triangle, I'm going to say 4 is A. So I have 4 squared plus B is over here. So B squared because I don't know it. And then how much is the hypotenuse? 5 squared. So take a second. You're doing 4 squared, 4 times 4, and then 5 squared, 5 times 5. And then this one, you're not adding them together. You have to subtract to both sides. We're going to round to the nearest 10th. Is this one like a whole number? Oh, okay. Oh, okay. Yeah. So B squared equals 9. So B equals 9 or 3. Sorry. So your height is 3. So we're going to plug it in and then we're doing 14 times 3. 42. So my area is 42. Easy peasy lemon squeezy. The only difference from elementary school to now is that we have to find the height. The height is not given. So let's jump over to number 3 because number 3 trips up people just because it looks weird. Okay. So number 3, technically you have a parallelogram. If I'm talking about area equals base times height, what is the base length to the parallelogram? No. Not 7. Not 6. It's just 4. So the parallelogram's this shape over here. So our base is just 4. I need to find the height technically of this distance of this parallelogram. So that's why it's off to the side. I'm still representing this piece, bless you. So we're not counting, we're not adding them together because it's just, this is 4 is the base. So my right triangle I'm using for the Pythagorean theorem is over here. Which number represents C? 16. So we're doing A squared plus 10 squared equals 16 squared, or you could put 10 at A and find B. It doesn't matter. It's the same thing. So oops. Is it? Okay. No, that's not right. 12.5. So if you round wrong, it's going to be wrong, especially on the EOC. So 12.489, the 8 makes a 5 go, or 4 turn into a 5. So 12.5. So I'm going to take my height. I'm going to plug it in, 12.5. So yeah, we just so happen to do the ones that come out as whole numbers. The other 2 are decimals, but it's okay. Whenever you multiply your decimal by your number, it's fine. No, do not round to the nearest whole number. Yeah, don't do that. Okay, so let's go down to a trapezoid. Trapezoid is another shape that you should have technically used at some point in your life. This may have been like in 6th grade. I don't really know. Maybe 5th, maybe 6th. This formula for a trapezoid is 1/2 base 1 plus base 2 multiplied by the height. This is on your reference sheet. You don't have to remember it. You just need to know how to use it. Okay. So let's start with number 6. So number 6, I have area equals 1/2 in parentheses. What is base 1? Just like whenever we did mid segments of trapezoid. 5 or 8. So I'm just going to use 8. So 8. What's base 2? 5. And then same thing. I need to figure out the H. The H is my vertical height. You're not using the slant height. So bless you. So if I have a little triangle over here. Now what's the problem with this guy? No, it's not. Well, yes. Okay, so if I have 8 minus 5, that makes 3. But you have to think, we have another side over here. Okay, so this distance represents here. So this piece right here kind of looks like a rectangle. That is 5. The whole thing is 8. So if the middle is 5, how much is left over? 3. And if I take 3 and divide by 2, I get 1.5 on each side. Because I subtracted, this is where people get confused. So I'll re-explain. So I took the 5, I moved it up. 5 minus 8 is 3. The reason why this distance is not 3 over here is because there's 2 sides. So I had to take 3 and cut it in half to represent 1.5 and 1.5. So whenever I do my Pythagorean theorem, I'm doing 1.5 squared plus b squared equals 3 squared. So if I take 5 and I scoot it up here, the whole thing is 8. If I minus 5 and 3, I get, or 5 and 8, I get 3, correct? But I can't just put 3 over here because the same exact triangle is also on this side. Yes. So this is like 2.25 plus squared equals 9 minus 2.25 minus 2.25. 6.75. 6.75. So because it's like a nice decimal like this, I would not round until the very end. If you start rounding within your problem and then you round again and then you round again at the end and then you round again at the very, very end, your number is going to be like off. So because it's only 2 numbers, it's nice, it's small, I would just use that entire decimal and square root it. If it was like crazy, most of the time it's like 3.4782189, whatever, blah, blah, blah. Then I would just like round it. But because these aren't too bad, this is where you're going to round it. So 2.59 is going to be 2.6. So now PEMDAS for life. Last time it was very easy. It was just base times height. What do I have to do first for this? Nope. I mean, you could, but that's not. I would just add it together. Yeah, 13. So I have 1/2. I add them together because parentheses, PEMDAS for life. So I would do 13 times 2.6 because let's not make our life crazy with the fraction yet. So 33.8. And then you're taking this and you're multiplying by 1/2, which is cutting it in half. So just divide by 2. So 16.9. Just put 16.9. It's not that terrible. Not like crazy. Okay, try number 5. So number 5, take a second. You're gonna have to make a right triangle somewhere. 5. Like the 1/2 at the very end, or like, are you talking about like cutting how we cut the 3 last time, make 1.5 and 1.5? You just divide by 2 because it's in the formula. You always cut it in half. Okay, so if I move the 10 down here, how much do I have left with 10 and 14? 4. Do I have to cut the 4 in half this time? No, because there's not 2 sides. So this piece is just 4 and that piece is just 10. So when you're doing your Pythagorean theorem, you should be doing 4 squared plus b squared equals 6 squared. It doesn't matter because either way you're adding them together. So it doesn't matter really which one's base 1, base 2. Well, day's almost over. You got like an hour left of your life. Then you can go sleep for 2 days. So if you take the square root of 20, what decimal do we get? 4.5. So you're setting up your area formula if you haven't already. 1/2 is in the formula. In parentheses, what two numbers am I adding together? 10 and 14. It doesn't matter which one's first because either way you're adding the parentheses together first. In the back, you're multiplying by the height you just found, which is 4.5. So if I add them, I get 24. Yeah. It's base 1, which is the top, like mid-segment formula. Yes. So 24 times 4.5 is 108. Cut in half
54.
is 54. So the one, it just so happens that the ones that we did together, the like aren't decimals. But if you get a decimal, just round to the nearest tenth in the end. It's not a big deal. The rest of them basically are decimals. There's like, yeah, there's two that aren't decimals. It just so happens I did all the ones that are not decimals, of course, you know. It's how the ball usually rolls. Okay. On number 7, you can cross out number 7 because technically this is weird. It's supposed to be a 13 instead of an 11, but it's okay. You can just skip number 7.
So cross that.
Yeah, because the number's wrong. So like there's no